Landing on a comet is one of the hardest things that has ever been done by the human species.
This is the comet. It's roughly a 1 in 1,000 model, so the real thing is 1,000 times bigger. The landing site is roughly here, which we're aiming for to deliver the lander. It's the flattest part we could find. What we are studying at the comet with the instruments are basically what are the ingredients, which materials are present, and coming back to one of the objectives of the mission, how complex are the materials present at the comet.
Landing means flying very, very slowly over the comet and then gently pushing away the lander. It's not a landing like you can imagine on the moon, where you come with rockets and you have to brake. Here the problem is the opposite. You have to really touch gently the comet. The forces involved are very small.
If I get meaningful data, that would be just marvelous. If the descent works, the landing is okay, we receive a sample, and the whole thing runs smoothly, that would be just great. But we need a lot of luck, really. And we had a lot of luck already.
So we are sitting on the surface. Philae is talking to us, more data to come and to be analyzed right now. Going down, which it should do, of course. We are there, it's done its job. We are on the comet.
The science has started now. We have the first results that give us the first comprehension of what we think the comet is, where it started from. Now, for the rest of the year, we'll watch how the comet evolves. We'll unlock how the comet works. We're looking at where the gas and the dust start to accelerate from the surface and how that beginning of the coma, that birth of the coma works. So how the coma develops as it does to higher altitudes. This region has only ever been theoretically constrained or modelled. These will be the first measurements we make in this area or this region, and that's a really big, important target for us.
Eventually, the tiny probe shut down.
Having Philae reactivated is not so likely, but it's not impossible. Philae was designed to hibernate, was designed to switch off and be able to reactivate itself. Of course, we expected this to be a duration of a few days or a few weeks, not a few months. But okay, we will see. Maybe we are lucky and the units have survived these months and will reactivate in June, July.
While observing the asteroids, scientists were surprised to find one with what looked like a cometary tail. After careful study, scientists realized they were observing the results of the impact of 2 asteroids. 596 Sheila had been struck at high speed by a small asteroid. The impact hit with the force of a 100-kiloton nuclear bomb. NASA had done something similar with Deep Impact, a probe sent to Comet Tempel 1, where it dispatched a kinetic impactor which struck the comet to study the impact and the debris thrown up as a consequence. Soon after, NASA launched another small ion-powered probe, Dawn, which also had an extraordinary mission: to travel deep into the asteroid belt between Mars and Jupiter. Its targets, 2 of the largest asteroids in the solar system. Dawn rendezvoused with 4 Vesta and orbited it for over a year, returning a wealth of data. Dawn then departed and cruised towards Ceres, the largest of the asteroids, a planetoid, where it has obtained orbit and begun its study.